Hi everyone. Today, whenever you look at this video is going to be about this guy right here. Okay, so it's going to be about growth and decay functions. You've been seeing a lot about these in the news lately. Growth and decay functions. Every time you see a coronavirus, is the curve flattening? All that kind of stuff. They're talking about growth and decay functions. Okay. So let's take a second to look at growth and decay functions first. So on the blog, there's this helpful little chart that you would have put in your notes if we were in class. So generally, our growth and decay function looks like this. It has some starting amount, which is the A, and then it has a rate of change, which is the R, and it can be either a rate of increase or growth, in which case it's 1 plus R, or it can be a decay function, in which case things getting smaller, like 1 minus R. This stuff's used in science a lot, all right? And I have two science examples here. One is growth, okay? When germs get inside of you, they grow very rapidly, and this shows 75% growth per minute. So you start out with a really low number of cells that are flu, 500, and your body has billions of cells. That's a really small number. But after 4 minutes, it's increased by almost 10 times from 500 to 4, 6, 8, 9. That's the characteristic of a growth function. Right? Decay function is just the opposite. When you take medicine, for instance, they say take aspirin every 6 hours or something like that. The reason is that you take 400 milligrams of aspirin, and then the amount of aspirin in your body slowly decays over time, and maybe your headache comes back, and you need to take another aspirin after 6 hours. So that's a growth and decay function. All right. And we're going to look at growth and decay functions. And this is a pretty simple exercise. They just want to know, is this a growth function or a decay function? And what's the change? What's the percent increase or decrease? All right. And that's pretty easy. Also, there's a little helpful here. So we're going to look at this and we're going to try and match up our is the rate, which is the in the parentheses is the rate. So it says 0.25. So is that a growth function or a decay function? Well, if 1 plus R is greater than 1, well, that's not greater than 1. It's less than 1. 0.25 is less than 1. That's over here. And actually, this example is the exact problem we have here, which is cool. All right. And so what you're going to do is figure out the percent change, and all you do is take whatever is in the 1 point R and you subtract 1. All right, so we are going to do that over here. I'll do a few of these. All right, so we have y equals, actually let me do this in a different color, because the only part of this that you really care about, you have all this stuff here, and the only part you really care about is this part right here that's inside the parentheses. You can ignore everything else. It's always nice in a problem. All right, and what you're going to do is you're going to take this 0.25, made my arrow wrong. All right, so you're going to take this 0.25 and you're going to put it right here, 0.25. All right, and then you're going to subtract 1 from it. All right, subtract 1. All right, and that's going to give you, if you do that in your calculator, it's going to tell you that it's a negative 0.75. All right, so we see that this is a negative change. All right, so negative change means decay, getting smaller. All right, and so that was a simple part. And then the next thing is we want to take this answer up here, this answer, and we don't care, and now we don't care about the plus or the minus because we already said it was decay. All right, we're going to take this and we're going to multiply it times 100 to change it to a percent. All right, so 0.75 times 100 is equal to 75, and we put a percent behind it, 75%. All right, and we come over here to our delta math, and we have this box which says, is it growth or decay? And you say, of course, it's decay. And then how much is it decaying? And we said 75. All right, so we are going to say 75 and submit answer. And what do we get? Green check. That's awesome. Let's do another problem. Get rid of our stuff here. All right, and in this case, again, I'm going to write the problem. I'm going to put in black here, 21, and the only part that we care about is what's inside the parentheses, 1.08, and we can ignore everything else, x. All right, so what are we going to do? All right, we're going to bring this 108 right here. We're going to subtract 1, and that's going to give us an answer of 0.08. And we are going to note that this is positive. It's a positive change, so that means it's a growth function. All right, and then the next thing we're going to do is we're going to multiply this times 100 to change it to a percent. And so 0.08 times 100 is equal to 8%. All right, so we go over here. Well, it already says growth, so we don't have to change that. And we submit our answer. And so we got an 8% increase. And we got another check mark. All the problems are just that easy. All right, so they're either growth functions, and they look like on the left here, or they're decay functions, and they look like on the right. Every time you do the same thing, you subtract the 1 plus r piece, you subtract 1. If it's positive, it's a growth. If it's negative, it's decay. Change that to a percent, and you got your answer. There you go.